To solve this problem, what we need to take into account is that they are asking us for only the 3 first terms in these sequences, and we need to base it in this n term. So remember that when we have these n's, what they represent is the number of the like the spot on the sequences, which means if I write 1 here and 1 here, I'm searching the first term of our sequence. If I write the 5, it's because I'm finding the 5th term. So as we're being asked to give the 3 first one, we're doing that. So let's start with the first term, which will be 1, because it's the first term, brackets 2 times 1 again, because it is an n here, plus 3. Then we solve this. Remember, because of the PEMDAS rule, we start with the brackets and the multiplication first. So we will have 2 times 1 is 2, so plus 3. And then we solve this bracket. That will be as a result of 5. And we have the 1 here, and we multiply these two terms, and 1 times 5 is 5. So this is the first term of the sequences. For the second term, we do this exact same thing, but instead of a 1, we're putting a 2. So 2 parentheses 2 times 2, remember because of the n, plus 3. Now that we have that, let's solve the bracket. So 2 times 2, 4, plus 3, and we solve this bracket, so will be 7, because of 4 times plus 3, which is 7, and we have 2 times 7, which is equal to 40. And this is the second term of our sequences. Finally, for the third one, we're going to do instead of the n, the 3. So 3 brackets 2 times 3 plus 3. And we solve the parentheses. This multiplication will be a result of 6. So we have here the parentheses now. And to do this, the answer will be 9, because 6 plus 3 is 9. So we have 3 times 9, which is equal to 27. And that is the result of the third term of these sequences. Basically, and now we're going to put this together, it's our answer. So we have 5, 14, and 27. Remember, as we're talking about a sequences, it means that it is going longer. So we put another comma and 3 dots to represent that it's not the end of the sequences. And that is our answer. In this problem, we have the terms of our sequence. What we need to find is the next 3 terms. So in this case, we can start by seeing that from having 11, we have 6. What we need to do to have this change in the number? Well, in this case, it is minus 5, because 11 minus 5 is equal to 6. Then 6 and 1, which have a difference also of minus 5. 1 and minus 4 have a difference of minus 5 too. Minus 4 and minus 5 also have a difference of minus 5. So as we can see, the difference of this sequence is minus 5. Now that we know that, we can find the next 3 terms, which in this case, and taking into account that the last term we know is minus 5, we can say that minus 5 minus 5, because of the difference, it's equal to minus 14. So that will be the next that it's going to be next to it. So minus 14. Now that we know that is minus 14, here we're gonna take minus 14 minus 5, and that will give us a result of minus 19. So that will be the next term, minus 19. And finally, as we know that it's minus 19 now, minus 19 minus 5, it is equal to minus 24. And that is the last term that we need to find in this case. So the three terms are minus 4, minus 19, and minus 24, leaving our sequence like this: 11, 6, 1, minus 4, minus 9, minus 14, minus 19, and minus 24, and that will continue and so on. Now we can also have the n term, the formula n term, which in this case, remember that the difference is minus 5. So the first thing we're gonna write is minus 5, the n that is representing the position of the term that we're looking for, and from that we can start. Let's take as an example the last term that we find. In this case, it is the 8th term of the sequences. So imagine having this like minus 5 times 8, that will be a result of 40, minus 40. When we have minus 40, we see that obviously it is not what we're looking for, because it will be really different than minus 40, and we're looking for a minus 24. So the next step is what we can add here in this formula to make it correct, so it gave us a correct result. What we can add to this is plus 16. When we do that, we have a result of minus 24. And look, we have the same answer as here. So we know that this is what we need to add in our formula. So we have minus 5 n term plus 16. And this, guys, it is our n term. And we can do it with every single of these by replacing the position of that number, that term in the end. So we were looking for, I don't know, the next term here, which will be the 9th term. We put a 9 here and do that operation. That's it. So remember, this, the next three terms of our sequences that we were given, and this is our n term that we can also, by doing that, we can search the next terms, especially when they ask us for a number that is quite away from just a little number. In this case, they were the next three, so it's easier just to subtract that from the answer that we have previous. But if they ask for, I don't know, the 100 term, it will use this formula.